Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here you have information about online seminars and study manuals for exams PFM, IFM, and LTAM that I offer. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible, at least to the extent allowed by law, donation to support our students at Illinois State University, please go to smarturl.it/help-ISU-actuary. Here's a problem for today for exam FM on financial mathematics. A company owes $500 and $1,000 to be paid at the end of year 1 and year 4 respectively. The company will set up an investment program to match the duration and the present value of the above obligation using an annual effective interest rate of 10%. The investment program produces asset cash flows of X today and Y in 3 years. Calculate X and determine whether the investment program satisfies the conditions for Reddington immunization. And here's the solution. So the present value of the company's surplus is a function of interest rate as follows. The surplus present value is X, the asset cash flow now, plus Y times 1 plus I to the negative 3, the present value of the cash flow of Y 3 years from now, minus 500 times 1 plus I to the negative 1, that's the present value of the first liability cash flow at time 1, minus 1,000 times 1 plus I to the negative 4, that's the present value of the second cash flow at time 4. Matching the present values of the assets and liabilities would require the surplus to be equal to 0, and thus the following equation to be satisfied, that X plus Y times 1 plus I to the negative 3 must be equal to 500 times 1 plus I to the negative 1 plus 1,000 times 1 plus I to the negative 4. And we are given that the interest rate is 10%, and that would mean that X plus Y times 1.1 to the negative 3 must be equal to 500 times 1 plus times 1.1 to the negative 1 plus 1,000 times 1.1 to the negative 4. The sum of those two expressions is approximately equal to 1,137.55891. If the present values are matched, then matching durations implies that the derivative of the surplus function is 0. So the derivatives of assets and liabilities with respect to the interest rates, or the dollar duration or money durations of both are equal to each other. And therefore the surplus derivative as prime of I, which is has to be 0, and that derivative is equal to negative 3 times y times 1 plus I to the negative 4 minus negative 1 times 500 times 1 plus I to the negative 2. So we just take the derivative of each of the terms, minus negative 4 times 1,000 times 1 plus I to the negative 5. And then we plug in the interest rate of 10%, so I is equal to 0.1. And this expression that we have becomes an equation that 3y times 1.1 to the negative 4 must be equal to 500 times 1.1 to the negative 2 plus 4,000 times 1.1 to the negative 5, so that y has to be 500 over 3 times just divide both sides by 3 and multiply both sides by 1.1 to the 4th. So we get y is equal to 500 divided by 3 times 1.1 squared, which is what you get when you multiply 1.1 to the 4th times 1.1 to the negative 2, plus 4,000 divided by 3 times 1.1 to the negative 1, which is what you get when you multiply 1.1 to the negative 5th times 1.1 to the 4th. And then y we calculate to be approximately 1,413.78788. And now that we have the value of y, we can calculate the value of x, because we established before the relationship between x and y. So x is approximately equal to 1137.55891. That was the right-hand side of the equation, where we established that x plus y times 1.1 to the negative 3 is equal to this expression. That was the very beginning of our work. Now we plug in the value of y that we just calculated, and we subtract that value of y of 1668.3333 and so on, times 1.1 to the negative 3. We subtract that expression from 1413.78788, and we get x to be approximately 75.3591512. So that's what we know that x and y have to be. But what we established is that these values of x and y will make the present value of surplus equal to 0, and the derivative of the surplus with respect to the interest rate equal to 0. That doesn't mean that Reddington immunization conditions are satisfied. Now we will try to establish if they are. One additional condition for Reddington immunization, in addition to equal present values of assets and liabilities and equal durations of assets and liabilities, is that the second derivative of a surplus with respect to the interest rate should be positive. This condition is equivalent to convexity of assets exceeding convexity of liabilities. In this case, the second derivative of a surplus is negative 3 times negative 4 times y times 1 plus I to the negative fifth minus negative 1 times negative 2 times 500 times 1 plus I to the negative 3 minus negative 4 times negative 5 times 1000 times 1 plus I to the negative 6. For the interest rate of 10% and y known to be 1413.78788, we plug those in and we obtain that the second derivative of surplus is equal to, for that value of I of 10%, so I here is 10% specifically, 12 times 1413.78788 times 1.1 to the negative fifth minus 1000 times 1.1 to the negative third minus 20,000 times 1.1 to the negative sixth, and we calculate all that and comes out to be approximately negative 1506.5809. And this means that the second derivative of surplus as a function of interest rate is negative, and any small change in interest rate will actually result in a loss of surplus to the company, as the surplus as a function of interest rate has a local maximum at the interest rate of 10%. And Reddington immunization conditions are not satisfied. This is actually bad news. Whatever happens to interest rates, at least within a certain small range, the company will be worse off after any change in interest rates. They will lose surplus. Which is kind of a lesson to learn that matching durations is not something that always protects you from interest rate risk. It protects you if you have assets that have higher convexity than your liabilities. And that means that the assets are more spread out over time, the payments of assets, the cash flows of assets, or that assets are relatively long-term in terms of their maturity or duration. Anyway, this is answer choice A. Please remember this is copyrighted material. The problem itself belongs to the Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.